Hi, my name is Bianca, and I'm going to present my work that I developed with my advisor, Dr. Rogério, that is called Exploring Popular Software Repositories, a study on sentiment analysis and commit clustering. This is an outline about what I'm going to present. And to give you an introduction, repositories are available sources of information that can help us to answer research questions, help managers to manage their project, and other purposes. In repositories based on Git, it's possible to find comments about the modifications made, and there is a convention of how it can be written, but it's not mandatory, so most people don't use it. It would be much easier to do research if people use the convention, but they don't. So mining software repositories is a research area that can help us to study what is happening inside the repositories, and it is a research area that supports the improvement of the products of the software development process, maintenance, and projection of tasks. And to Constantino in 2017, he points that GitHub is the best platform to get this information because it has an API, but also because it has public data sets available in other sources like BigQuery, for example. And in this paper, the goal is to group the commits by messages and compare the sentiments obtained from the commit messages and other information that we can get from the data set available, and answer the research questions, which are: 1. Do programming languages influence the distribution and the group proportions? The groups are the groups that were found by the analysis. The second one is, do the activity type influence the sentiments? The activity type is the activity type that we could analyze when we look at the groups. Third one is, do the sentiments in the commit reflect the popularity of the project to which it belongs? 4. What are the language's influence on the sentiments? 5. Do the activity groups relate to the repository's popularity? All queries, dataset, and code that we used in this paper are available in my GitHub repository, and this is the link here. So first, we have to talk about the theoretical framework and about the data mining process. First, we have to pre-process the data, and the primary goal of pre-processing is to prepare the data for the data mining, and it can involve a series of tasks, and they are not all mandatory, but we can look at the data set and see what needs to be done so we can prepare the data. The tasks are aggregation, sampling, dimensionality reduction, feature subset selection, discretization, binarization, and variable transformation. After that, we can do the model construction, and we have three common types of clustering algorithms: hierarchical partitioning and density base. Inside the density base, there is an algorithm called dbScan, which has automatic cluster number detection, capacity to handle clusters of different shapes and sizes, and it can determine the number of clusters by analyzing the density of the instances, and it is not sensitive to the presence of outliers when grouping the instances. After that, we can do the post-processing that has the purpose of visualizing and interpret the patterns that were found after the data mining process, and we can do that by doing the internal evaluation, comparing the groups, the clusters, and studying their relationship within the relationship within and between the clusters using metrics. And we can also do the visualization We can apply PCA to reduce the dimensionality, so we can plot the instances in a scatter plot, for example. And we can also examine the most frequent words in each cluster, so we can understand why they were grouped that way. After that, we can apply the sentiment analysis inside the data set, so we can see if the message has sentiments negative, positive, or neutral. And talking about the methodology that was used, first we had to do the data acquisition. We used Google's BigQuery tool to perform queries that selected the 20 relevant repositories for the five most popular languages, which are JavaScript, Ruby, Python, PHP, and Java. And the datasets that we could get is available in my GitHub repository. And this is the link again. After that, we can apply the pre-processing, First, we had to do the data cleaning by removing empty values, converting words to lowercase, and removing the stop words that will not be useful. And we used only alphabetical characters and English words. And we also applied stemming, removing prefixes and suffixes from the words, so they will be in the root or base form, and everything to reduce the dictionary of words of the dataset. And we apply also feature subset selection by applying TF-IDF that assign weights to the words, to each word in an instance. And we had to reduce the dimensionality by using PCA, because TF-IDF creates a new column to each word in the dictionary, so we applied PCA to reduce the dimensionality. And for the model construction, we use dbScan, which has two main parameters, mean samples and epsilon. And first, we chose these parameters manually, and after that, we refined it using the silhouette value. And for the post-processing, we analyzed the indexes, but also we did the visualization, the visual exploration of the groups, so we can see why they were grouped that way. And after that, we also apply the sentiment analysis to see if the message is positive, negative, or neutral. And this is the data set we could get, the groups that we could get. And here is the groups that were found, and I'm going to talk about why they were named that way. But this is the distribution of the instances without the outliers, of course, because they are not interesting for us in this moment. So this is the groups. The first one has these words as the most frequent ones, and that's why we named it as fix and add group. The second one is more like a merge or a pool of add activities, and the third one is a merge and pool of fix activities. So that's why they were named that way, and these are the most frequent words in each group. And after that, we can answer the research questions by analyzing the results. The first one is, do programming languages influence the distribution of group proportions? Yes, it does. We can see here in this visualization that shows the the clusters and the quantity of the instances of each cluster in each language. And we can see that Java has less merge and pull than the other languages. And there's a clear difference that we can see here. The second one is, do the development activity influence the sentiments expressed in the comments? Yes, it does. We can see here that surprisingly, analyzing the second and the third group, surprisingly, the merge and pull of add has less positive comments than the merge and pull of fix. And this is a difference, a significant difference. The third one is, do sentiments expressed in commit comments reflect the project popularity among the developers? We can see here that also surprisingly, the high popularity repositories have more negative comments than the other ones and more negative comments than positive ones. And the less popular ones have more comments with positive messages. So yes, it does reflect the popularity among developers, but not in a way that we could assume before. Four is, do the most used programming languages influence the sentiment expressed in comments? Yes, it does. We can see here that JavaScript has more negative comments than positive ones, and more negative comments than the other ones. And Ruby is the opposite of JavaScript because it has more positive comments than the other languages, and more positive comments than negative ones. So here we can see that despite JavaScript being more popular than Ruby, it has more negative comments, and it is the opposite. So we could do research to to find out why this happens, but in this research we just noticed that there is an influence. And the last one is, do the most recurring activity within the project have any relation to the repository's popularity? Yes, it does. We can see here that in the high popularity ones, we have less merge and pull than the activities. Then in the other ones, we have more direct activities, which are fix and add. And the conclusions are that negative reactions might suggest the prevalence of issues that can impact the software quality. That's why it needs to be studied. And languages can influence the sentiments that are expressed. There is a limitation of the data acquisition because the limited API requests that we can get from GitHub, but we can get this information from other sources like BigQuery, for example, that we actually used. And similar challenges about the data acquisition have been faced by other studies, but yet yielding significant results. And the exploration of the data acquisition challenges is crucial for ensuring the reliability of the study conclusions. So that's why it is important to get the data from a reliable source. And this study was partially financed by the Coordination of Improvement of Higher Education Personnel, Brazil. And these are the references, and thank you very much for the opportunity.